are various types of transformers. They all operate on the same fundamental principles while employing different construction methods. Transformers are essentially voltage control devices that transfer alternating current power from one circuit to another. What does a transformer do? Transformers are incredible devices that enable us to achieve two primary functions. Increasing voltage while decreasing current, these are called step-up transformers. Decreasing voltage while increasing current, these are called step-down transformers. Basic components of a transformer. There are three essential components in transformers. The iron core, which provides a path for the magnetic lines of flux. The primary winding, which receives energy from the AC source. The secondary winding, which receives energy from the primary winding and delivers it to the load. How does a transformer work? There are three key concepts we need to know to understand the working principle of a transformer. First, when a current flows in a wire, it creates a magnetic field. This is what we called electromagnetism. But if the alternating current flows in a wire, it creates a changing magnetic field. Finally, a changing magnetic field induces an alternating current in a nearby coil through a process known as electromagnetic induction. By combining those, we can understand how a transformer works. When we apply an alternating current to the primary winding of a transformer, it creates a pulsating magnetic field. As the changing magnetic field reaches the secondary coil, it induces an alternating current in the coil through electromagnetic induction. The transformer's core helps direct the magnetic field between the coils, minimizing energy loss. Let's consider the number of turns in each coil. NP is the number of turns on primary winding. NS is the number of turns on secondary winding. If the number of turns on primary coil and secondary coil are similar, the input voltage and current is equal to the output voltage and current. However, by increasing or decreasing the number of turns in the secondary coil compared to the primary coil, we can modify the output voltage as needed. When we increase the number of turns in the secondary coil compared to the primary coil, the longer length of conductor in the secondary coil is exposed to the primary coil's magnetic field. As a result, the voltage at the secondary coil becomes higher than the voltage at the primary coil. This is how the step-up transformer is constructed. Conversely, when we decrease the number of turns in the secondary coil compared to the primary coil, the shorter length of conductor in the secondary coil is exposed to the primary coil's magnetic field. As a consequence, the voltage at the secondary coil becomes lower than the voltage at the primary coil. This is how the step-down transformer is constructed. More precisely, the ratio of the primary voltage to the secondary voltage is equal to the ratio of the primary turns to the secondary turns. However, it's essential to remember the principle of power conservation in a transformer. Power cannot be created or destroyed. It remains constant. To ensure power equality, if the voltage is increased, the current must decrease, and vice versa. Thank you for watching us.